Hello, this is Suyong from UT Austin. Motivated by the problem of demographic-specific toxicity detection, we introduced a new conditional multitask learning framework. One challenge we encounter when building a toxicity classifier for content moderation is that toxic language has commonalities and differences across the different groups for which it targets. When building a model, we would like to learn these general patterns of linguistic toxicity while distinguishing the differences. But a one-size-fits-all approach risks overfitting forms of toxic language most relevant to the majority groups, potentially at the expense of systematically weaker model performance on the minority groups. This also raises concerns of algorithmic fairness. So we pose the question, can multitask learning help? We propose modeling demographic-targeted toxic language via MTL. MTL combines shared and task-specific layers, which allows the model to specialize on relationships relevant to different groups while leveraging shared properties across groups. In traditional MTL, we assume that each training point is labeled for all tasks. However, that is not the case in our toxicity detection setting, as this would mean that a post targeting group green is labeled as non-toxic for group orange. We refer to this as label contamination. Our conditional MTL approach is capable of learning group-specific representations of toxic language over sparse labels. We introduce a task-specific, conditional representation of labels and avoid labeling instances which do not belong to a particular group. This updated labeling schema, combined with a novel conditional loss function, allows for model training without contamination. We use the civil comments portion of the WILDS dataset for evaluation. In general, toxic language is rare, comprising around 15% of posts in this dataset. We present results on the toxic class here, for which the traditional MTL model performs poorly, likely due to the label contamination issue discussed earlier. One could also use a stacked single-task learning model in which we build 3 models which are trained on different portions of the dataset. Training the stacked STL model is significantly more expensive in both time and space, but yields improved performance over the traditional MTL model. Conditional MTL, which is more time and space efficient when compared with the stacked STL, achieves better F1 values. We hypothesize that this is because conditional MTL does not suffer from label contamination while being able to learn both the general patterns and differences in linguistic toxicity. To summarize, toxic language has commonalities and differences across the different groups for which it targets. Conditional MTL allows us to model both the commonalities while tailoring predictions for the differences, giving us the best of both worlds. For more information on our work, please visit us at FATE Research Session 1.